Hello everybody and welcome to our presentation. Today we are going to talk about such remediation method as burn-in and volatilization, and this is our group. Our group is going to present first of all the history and introduction of the method. Then we're going to talk about advantages of thermal treatment and disadvantages of thermal treatment. Then we're going to provide a case example and the conclusion about our method. And first, I am going to tell you a bit of history and background of the method. So thermal treatment, it first appeared and has been developing since 1980s, and thermal desorption, in particular, first appeared in 1985. And so over the last 15 years, such more modern ways as or ways of in situ thermal soil remediation as electrical thermal conductive heating and steam injection have been popular. And first introduction of thermal treatment. What does it actually mean? What it is, the thermal treatment? So it is called in situ thermal treatment because in situ means that the heat is applied directly to the contaminated area, so not afterwards, but at the site. And the thermal treatment methods move harmful chemicals in soil using heat. So they heat the soil and then the chemicals evaporate to the ground through soil and groundwater. And after the chemicals leave the soil, they are collected afterwards above the ground. They are collected and processed with other cleanup methods. And during the heating process, some chemicals are destroyed or broken down. Then the technology in general, how does thermal treatment work? So when we have the contaminated soils, we have to heat them using heater wells, and the heater wells they heat the soil basically to very high temperatures, and then the chemicals, the contaminators, they evaporate and turn into vapors. So that is like much easier for them in this kind of stage. It's much easier for them to leave the soil, and after that they are extracted to the surface, vacuumed, and treated. Now, a little bit of types of thermal treatment technology, so how they can differ, what are the differences. So we have electrical resistance heating to start with, and then the two methods that have been developing lately is steam-enhanced extraction and thermal conduction heating. So first about the electrical resistance heating, ERH. How this method works is using the current, and a current is generated underground between electrodes, which are secured there underground. And the heat occurring as a result of the movement of the current faces resistance from soil, and it converts water in soil and groundwater into steam, by which contaminants are vaporized. The next method is steam-enhanced extraction, and again, basically the core of this one is seen in the name of it. So steam-enhanced extraction, that means that during the process, steam injection into wells and extraction of hot fluids occurs. It is used for remediation of a wide range of contaminants, as we can see here. And then the last method that I have here is thermal conduction heating, which is basically one of the modern ones, one of the more expensive ones, and it's pretty efficient. So here we can see that this method uses heaters placed in underground steel pipes. Then thermal conductive heating technology can reach temperatures at several hundred degrees. That means that it can treat almost any organic contaminant from low to high boiling point. Then the heating process is from 3 to 6 months, and at the end of it, almost all of the contaminants are removed by the process. And now Tatiana is going to jump in and present the advantages and disadvantages of our method.
This method has its advantages and disadvantages. And to start with a positive point, one of its biggest advantages is a fast remediation. It will last from only a few months up to 2 years, which is much faster than using other methods. However, there is also no transportation needed, so that the ecosystem of this soil won't be destroyed completely, even though it can be hurt by temperature. But still, there is no need to find a place where this soil should be placed, and also there is no need to pay money for transportation. Moreover, it's possible to use this method below buildings so that it would be really easily used in places where the factories are located. Those factories can contaminate the soil, while this method will remediate heat, not requiring the destroying of the building or even sometimes stopping of the work of this building. Finally, the heterogeneous or solid soils are not a big obstacle for this method, as the temperature can get almost everywhere without any problems, so that it would get deep into the soil, and also it will get through different types of soil. However, there are some disadvantages. One of it is the fuel that is required. It can be gas or some other fuel, but still it will be used and then the source will be diminished. Also, it will lead to some air pollution that can happen due to smoke or anything else from heating, and even though there are some machines collecting the air pollutant, still some pollutant will come to air. Moreover, this method is unfortunately not suitable for inorganic contaminants except some metals, so that it won't be remediating the soil completely. In addition, this method costs quite a lot for a short period of time. And this is not really logical for some governments or just some people to use it to remediate. Finally, for each type of soil, for each situation, there is a lot of preparation and supervision needed, as this method is not adjusted for every situation and should be counted and thought out before the issues really a lot.
Our case example is slash and burn clearing. Finnish name is kulotus. Horseshoe technique is a traditional Finnish slash and burn clearing technique where the fire is ignited from below the wind and the fire front is led upwind. It is carried out during a dry period when there is a risk of wildfire. The fire alloy stops the spread of fire. An irrigation system is carried out around the area and the outside terrain and timber is irrigated as required. Medium nutrient soil is suitable for slash and burn clearing. In loose lands there is no need for it, and in the dry lands the soil might burn too thoroughly. Soil should be water permeable moraine soil. The burning's aim is to paraphrase the natural circularity of the forest. Species that rely specifically on wood material damaged by fire are targeting the fire area. Burning improves the nutrient and thermal conditions of the breeding site. In successful slash and burn, most of the logging leftovers and some humus layer are burned. Nutrients bound to logging scraps and the humus layer are released for plant use, and the acidity of the soil decreases even for decades. The heat insulating humus layer is thinning and the thermal conditions of the ground are improving. Competition for surface vegetation decreases for a few years after the burning. Forest farming work becomes easier when logging scraps have been burned. Conclusion: it is a successful method of soil remediation. However, it also has some effects on environment which need to be taken into account.